Okay, so once again, I do hope you guys are having a great day. And last time we got into this topic of factoring. And what we discovered was a really interesting way of how to factor. We found out if you have a quadratic, remember that's a polynomial whose degree is going to be 2. So something of the form of x squared plus bx plus c, if there is a 1 in front, what you're going to do, the steps are, you're going to look at the constant term in the end, you're going to factor c, maybe in terms of a p and a q, then you're going to look at all different factors and see what adds up to the value in between the b, where you have your p plus q. And as soon as you identify the p and the q, the factors, this is going to factor as x plus p, x plus q. So kind of point in case, if I have x squared plus 9x plus 14, if I want to solve this, I don't want to look at the x squared and I don't want to look at the 9x, I just want to look at the 14. It's possible that I may not find a factorization. That's okay. In those situations, I would just say the polynomial is irreducible or the polynomial is going to be prime. We can't factor it. At least we can't factor it yet. 14, I'll break it apart. I'll have 1, 14, and 2 and 7. And I also do want to consider from time to time the negatives, -1, -14, -2, -7. But in this case, again, when I'm factoring, I do want to use strategy. I don't want to really just put it all out there. I'm going to use some strategy to reduce my workload. And I do see that both these values are positive, so I'm probably not going to worry about the negative factors. If one of the signs up here was negative, then I might want to consider one of the negative factors. So I would just ask myself, what sums the value of 9? And we see very clearly it's going to be the 2 and the 7. So this will factor as x plus 7, x plus 2. So it's not too bad when I have a 1 from the x squared. The problem does become substantially more complex when there's not a 1 from the x squared. And the process that I showed you guys last time was, if I have that kind of situation, what I'm going to do is just look at different possibilities and hope for the best. And if it works, great. If not, then I'll move on with my life and call it a prime polynomial. So if I have something like 3x squared, 2x plus 1, what I want to do in this particular case is just focus my attention on the leading coefficient and the constant at the very end and ask myself, what are its corresponding factors? In this case, there's not that much to check because here, 3 is a prime number, 1's a unit, so we're in good shape. And so here, if this is going to factor, I know it's going to factor as 3x, x, and then a 1 and a 1, since those are repeated. If this works, we got it. If not, we would call it's going to be a prime polynomial. And I don't know what I know until I know what I know, if you know what I mean when I say I don't know what I know until I know what I know. I have to roll up my sleeves, I got to get to work, and I got to try something, and I got to be courageous enough, willing enough, daring enough to make a mistake. If I'm not courageous enough to make a mistake, I'm never going to take things to the next level. I'm never going to get that higher education. And that's what you guys are trying to do, is get that higher education. Well, here I just want to expand out. And I do see a 3x squared. I do have a 3x. And here, I'll multiply through, I'm going to have an x. And here, I'm going to have a 1. So I have 3x squared, I have 4x, and then I got 1. Is that what I have up here? No. So, since I'm looking at the integer coefficients to factor this polynomial, there's no other possibility. What I would say here in the end is this is going to be a prime polynomial or an irreducible polynomial. I cannot reduce it down anymore. Okay, so that's how I'm going to go about these. Now, let's just change the problem, tweak it up just a little bit. Let's say if there was a 6 right there instead. What I would do is the exact same process. I would look at the leading coefficient. I would look at the constant at the very end. And I would just ask, okay, how does 6 factor? I have a 1 and a 6. And I would have a 2 and a 3. Then I would look at possibilities. I would look at something of 3x and an x. And then I would say, okay, what if I connect it up with a 1 and a 6? I don't know where the 1 goes, if it goes up here at all. It's possible it can go here. I don't know. It's also very possible it can go there. I don't know. I don't know what I know until I know what I know, but I don't know it until I get to work and figure it out. So if I put a 1 here, I've got to put a 6 there. And if I put a 1 here, I got to put a 6 here. And in a very similar fashion, I'll have 3x x plus 3, or perhaps it's 3x plus 3 and an x plus 2. Now, again, use strategy. Make these problems a little bit easier, a little bit more manageable. And I see that there's a common factor between these two terms. I can see that 3 divides this piece and it divides this. 3 divides this, it divides that, but not the middle term. The only time that this could be a factor is if 3 is going to divide all 3 of these terms. It doesn't. So I already know before I go through the calculations that would be invalid, and likewise that would also be invalid. And again, I would just go through the calculations, I would expand out, and by design, how we're going about this problem, every single time, we're going to get a 3x squared and we are going to get a 6 because we are using the factors. So it's not really the first part that matters. It's not really the last part that matters. It's kind of like life. What matters is the in-between. From birth to death, what happens? That's what matters. Well, again, when you go about this, expand out, and if you don't find anything that's going to get you to a 2, then you're going to say that this is going to be a prime polynomial. We can't do anything with it, at least not for the time being. Later on, we'll be able to do things with it. We just can't do anything with it, at least for right now. Okay, now, these polynomials, once again, these are the easy ones to do. This one takes it to the next level. And if I can identify some kind of pattern that I can use, it might make my calculations a whole lot easier. And we looked at one of these last time. If I have something of the form of a plus b quantity squared, recall that we can take this and we can rewrite it as a squared 2ab plus b squared. And likewise, if it's a minus sign right here, you have a minus sign right there, and you still have a plus. So if I can identify this particular structure in a problem, I can factor it really, really quickly. So let's say if I have x squared, and let's say if I'm going to have 6x and then plus 9. If I see a perfect square in the end, oh, I get a little excited because I'm thinking that's probably going to fit the form because that's a perfect square. So 9 is going to be 3 squared. So if I took the problem and just slightly tweaked it for a plot of 2, let's see a 3 squared, I'm probably going to use this formula because it's going to go by very, very quickly. So I can take this, and I see that the a is going to correspond to an x. The b corresponds to a 3. And there's a plus sign, so there's a plus sign, so there's a plus sign. And that's how I can factor these kind of polynomials. Again, if I have x plus 5, if I square this out, The most commonly wrong answer that I see all the time on exams is students are going to say, you just take the x and you square it, and you take the 5 and you square it, and you go about your problem. So if this is a multiple choice question, and if a response, let's say question part A, if it was saying the answer is going to be x squared plus 25, and B, let's say it's x squared plus 5x plus 25, and then C, let's say it's going to be x squared minus 10x plus 25, and D, well, all A, B, and C is going to get you the wrong answer. And if this is a 10-point question, you just lost 10 points. The right answer is here. Because I do have a binomial, and what I'm going to do, square the first term, square the last term. Guys, don't forget about that intermediate term, the linear component, the linear term. So I'm going to have x squared, 5 squared, this times that times 2. Right there. Okay, so just be on the watch out that you don't make this mistake. That's not true. Now, let me throw you this. Suppose if I have x minus 3, x plus 3, and I want to expand out. To expand out again, I'm talking about foiling. So I can take the first term. I'll have an x squared, 3x minus 3x minus 9. And I want to simplify when I collect all my like terms, and that's just going to be this piece. 3x minus 3x gets me 0. So what I find out is when I expand, this is going to be x squared minus 9. Now, this corresponds to a certain identity. You might have heard it before, but it's called the difference of squares. And you'll never guess why it's called the difference of squares. It might be because we're taking the difference of. So, if I look at a polynomial, a quadratic in particular, if it says something along the lines of 4x squared minus 36, yes, I could go about the whole entire process. I could look at the coefficient in the front, the constant in the end, and see what's going to work out, go through a process of elimination. That will take some time. But what I can also do is observe that there's a difference between two terms. And when I see that, I get really excited because I know how it's probably going to factor. All I have to do is figure out how I'm going to make this into a square minus a square. You figure this out, you got the problem solved. Well, the first part, I'm going to have a 2x all raised to the second power. And for the second part, I'll have 6 raised to the second power. So this is going to factor as 2x minus 6 and 2x plus 6. Now, you can always go back and check, distribute. 2x times 2x will get you a 4x squared. 2x times a 6 gets you a 12x. Minus 6 times a 2x gets you a negative 12x. But a 12x minus a 12x zeroes out. And what you're left with is a negative 6 times the 6 gets you 36. Okay, so if I see this kind of situation, I want to use this property. And if I see some kind of polynomial where it's a squared minus b squared, using the difference of squares can greatly increase the computational time to go through the problem. Now, the contrast is, if I have a squared plus b squared, this is called you'll never guess what it's called, maybe a sum of squares? It's very descriptive, isn't it, math? But anyways, when I look at a sum of squares, they're prime. I'm not going to be able to factor these. So let me throw you one up here. Let's say if I have, now at first I might think, what do you mean it's prime? Of course I can factor it. Because I can say x plus 2 and I raise it to the second power. But if I have x plus 2 raised to the second power, what does that tell us that we have to do? Square the first term, square the last term. Don't forget about the piece in the middle. That piece right there. That's going to be x times 2 times 2. So that's 4x. So I'm not going to be able to factor this. So when I see sums of squares, prime polynomial. And that's something you want to write down in your notes so you don't forget it. When I have a difference of squares, yes, I can factor it, and I can factor it in less than 10 seconds. Because all I'm going to do is just use this identity. So should I know this identity? Absolutely. Absolutely. We're going to come back to this many, many times throughout the course. When I see a sum of squares, well, I'm pretty much sunk. Now, there are some other identities that we also want to make sure that we are mindful of. And another one is sums of cubes. Now, when I see a sum of cube, something of the form maybe x cubed plus 27, guys, I can factor this. And the way that this factors is you're going to have a linear piece and you're going to have a quadratic. You're going to have a plus b. Then you're going to have a squared. You are going to have a b squared. And it's real similar when you're looking at the quadratic, where you have the a squared and you have the b squared. Things take a little bit of a change right here in the middle. Right here in the middle, you're going to pick up a ab, and you're going to have to reverse the sign. So if this is plus, that's minus. If this is minus, then that's going to be plus. So what I want to do when I see a cube is ask myself, is there a way to express it as a sum of cubes or as a difference of cubes? Because I can factor both of those polynomials. First thing is I might want to take 27, recalibrate it as 3 cubed. Identify that I'm going to be using this formula. We have x plus 3. We'll have an x squared. You will have a 9. You're still going to square that, but don't forget about the piece in the middle. And it's not 2ab, it's just going to be ab. So this is going to be 3x. And be mindful of the signs. Minus and then plus. And you can always go back to check your work by taking this and expanding out. So here we'd have x times x squared minus 3x plus 9. Then multiply by the 3. 3 times x squared minus 3x, and then the 9. And once you look at that, those terms go away, and you're right back to where you started. Okay, so make sure that you do know a plus b or a minus b quantity squared and how that expands out and how to take the expansion and put it back in the factored form. And also the difference of squares, and also know that when you have a sum of squares, you can't factor this. So if this was a problem on the exam that says factor the polynomial, that says x squared plus 1, there's no work to do. You got this answer in less than 5 seconds. It'll take you 2 seconds to write maybe some kind of response. Okay, so that's going to be sum of squares. It's prime. You're done with the question. Move on to the next one. If you see a sum of cubes or a difference of cubes, this is the identity that you're going to want to use. Okay, so let me stop here and see if you have a question about any of this so far. Okay, well, let's play a game real fast. And let's say if I have two numbers, a times b, and let's say equals 1. Okay, here's my goal. Here's my objective. I want to see if we can try to figure out the a and see if we can figure out the b. In fact, let me make it a little bit more interesting. If you can guess, and let's say it like this. If you can guess the numbers that I'm thinking about to satisfy this equation, I'll give you an automatic A in the class. You don't have to come any other day for the whole entire semester. You're done. Now, here's the other side. If you do not guess the number that I'm thinking about, automatic F in the class, doesn't matter if you get an A on all the exams here on after, you automatically fail. Okay, you guys ready to play? Ike, what am I thinking about? Israel, what am I thinking about? What are the numbers I'm thinking about here? Oh, I'm so sorry. You failed. I was thinking of 5 and on the 5th. Double or nothing? You want to go again? Fail twice, I guess. How do you fail a class twice? I guess take it twice, but. You guys are kind of at a loss, right? Well, if someone says, well, you're thinking of 2, what I would say real fast is, no, I was really thinking of 3 and a third. And then someone would say, well, you're thinking of 3 and a third. And I'd say, well, no, I was thinking of pi times 1 over pi. Just to spice it up a little bit more. Or how about square root pi? Here's the real question. Would you ever win at this game? No. It's a rigged game. It's like one of those games you find in the carnival. You spend dollar after dollar because your little daughter is saying, Daddy, please get me one of those really big stuffies. Like, I'd rather go to Walmart and spend $1,000 buying one there than, because here I'm going to take out a bank loan and keep playing this game over and over and over again. So you can't win at this game because there's too many variables, too many abilities that A and B can take on. But what if I made a slight adjustment to the problem? Just tweaked it a little bit. Instead of saying 1, what if I now said 0? Could you win at the game? Could you at least find one of the numbers I'm thinking about? Absolutely. And this is what's called the, you'll never guess it, 0 property. See, a lot of times when you see these properties in mathematics, they're very descriptive about what's happening in the equation. Now, I still try to push the hippopotamus property, but that hasn't really taken on any traction yet. Hopefully one day, 50 years from now, maybe I'll get it, but probably not. People probably can still call it the zero factor property as opposed to the hippopotamus. But that sounds pretty cool, right? Hippopotamus. Did you know they actually have a hippopotamus day? That's kind of interesting. All right, anyways. The zero factor property. What it states here is this. If I have something that's been factored in something that equals 0, I can take my factors, I can decouple them, and I take one of the factors, I can say equal to 0. So one was going to be 0. I'm not for sure. They could both be 0, and that's okay, but I know one of the factors has to be 0. And this property allows us to solve our equations. Let's say if I have x squared plus 5x plus 6 equals 0. Well, in order to solve for x, what I'm going to need to do is use the zero factor property. In order to use this property, I have to do exactly what this set of instructions are telling me to do. Set of instructions? I don't see any set of instructions up here, like step 1, step 2, step 3. It's all baked into the equation, though. What you have to do is take that equation and make it look just like that. If it doesn't look just like that, you can't do just like that. So the first thing is, I do want to see if I have 0 on the other side of the equation. If I do, move on to the next part. Factor. Here's a quadratic. And luckily, there's a 1 in front of the x squared. So now how is this going to factor relatively quickly? Focus my attention on the constant 6 and see what sums to a value of 5 for the factors of 6. And I see that this is going to be x plus 2, x plus 3. I then take this, I decouple it, I take a factor, say equal to 0, and I take the other factor and I set that equal to 0. From which then I go ahead and solve my linear equations. Take the 2, throw it to the other side. Take the 3, throw it to the other side. Whenever I have a quadratic, I'm always going to have 2 roots. Now, the roots might be repeated, they might be distinct, but I'm always going to have 2 roots, 2 answers. When I have a linear, like I have here, I'm always going to have 1 answer. If I have a degree 3 polynomial, I'm always going to have 3 answers. They could be repeated, they could all be unique, that's okay, but I'm always going to have 3 answers. If I have a quartic, degree 4, you'll never guess how many answers I'm supposed to have. I'm supposed to have 4 answers. They can all be the same. They could be distinct. You have some are the same, some aren't the same. But I know when it's all said and done, I'm going to have 4 factors, and I'm going to have 4 answers. To solve the equation, what I want to use is the good old zero factor property. Now, here's what I don't want to do. I don't want to say, hey, look, it's factored. Hey, look, I'll just take this and I'll express this as that, and then solve my system. Let's play a game. You could think of the number that I'm thinking of, automatic A in the class. But if you don't, automatic F. Would you take that bet? No. There's lots and lots of numbers I can choose from. I can say 25, and I can say a fifth. I can say 25 over 2 times 2/5. Endless possibilities. You can't take this, you can't lock it down unless there is a 0 on the other side. So to use the zero factor property, what you're going to need is zeros and factors. All right, so here's how I approach this problem. I can take the 5 and I can just throw it to the other side. Okay, so you got your 0. The problem now is you no longer have any factors. Okay, so if I do not have any factors, would it be prudent then to start generating some new factors? Yeah, because in order to use the 0 factor property, I have to have 0, and the other side needs to be factored. Now, to go about that process, I'm going to have to take this and expand out a little bit. So I'm going to have 6x squared, 13x minus 5. Now, our luck hasn't really held out here in this case because I do have a polynomial which there's not a 1 from the x squared. So I can look at the coefficients, the leading coefficient, the constant at the very end, factor it, 1 and 6, 2 and 3, minus 1 and 5, 1, minus 5, and see what's going to merge, what's going to blend these things together. Again, I would just check different possibilities. Do the math technique known as cross your fingers. Maybe cross both of them if you want to. And say, please, 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 please. Okay, that's how I do my math. Cross my fingers and go, please work. And if it doesn't, then I say it's prime polynomial. There's no solution I can do here at the time being. Okay, so maybe I'll look at a 2x and a 3x and hope for the best. Okay. So here I'll have 6x squared. Here I'll have 2x minus 15x, and then minus 5. Did I find what I was looking for? Absolutely. Since I found what I was looking for, I should keep looking. No, you're done. If you found what you're looking for, stop. It's like saying, I found what I was looking for. Where'd you find it? It was the last place I looked. Well, I'm glad it's the last place that you looked. You need to keep looking. You wouldn't be done. All right, anyways. Just bad jokes. Hard being a dad. All right, so we're going to have 2x minus 5, 3x plus 1 equals 0. As soon as I have taken this equation, have rewritten it, so I have factors, and I have 0. Guys, it's time to celebrate because you're just about done. Take it, break it apart, 2 different pieces, solve for x. Divide by 2, divide by 3. And there's your answer. So what you're going to have to do at times is take your polynomial, which I had to say sometimes you have to expand it out so you can collapse it back down. Here's your goal. Solve. Solve for x. So let me give you a moment there to see what you're going to get. Okay, so let's take a look at it. To solve the problem, here's what I'll do. I see I have a factor, so I'll just say x plus 2 equals 2 and x plus 3 equals 2. And I'll say x equals 0 and x equals minus 1. I'm done. Is that right? What did I, if it's not right, what did I do wrong? What am I trying to do? I'm trying to solve for x, but I got a little confused because I solved factors, and I thought all you're going to do is take a factor that's equal to the other side. But you can only do that if one side's 0. Do you guys really want to play that game? Think of the number that I'm thinking about. Pass or fail. I don't want to play that game. So I can't just rush into the problem and do this. what I need to do is start creating zeros in factors. Okay, so I can take the 2 and I can throw it to the other side. Works out great. I do have the 0 now. That's exactly what I want. But by doing so, I created a problem for myself. I no longer have the other side being factored. So what does that mean? Well, I'm going to have to factor the side. Otherwise, I can't use the 0 property. Okay, so what I'm going to do is first expand out. I'll have x squared. Then I'll have 3x, 2x, 6. Start collecting my like terms. X squared, 5x, 4. Now, everything's been reduced down, it's been simplified. I got a trinomial, quadratic trinomial, fancy way of saying it, just a polynomial I have. I want to factor. Luckily, there is a 1 from the x squared. So all I'm going to do is focus my attention at the end and see what factors 4 sum to 5. And I see that this is going to correspond to an x plus 4, x plus 1. Then, once it's been factored, and I have 0 on the other side, I'm going to take this, break it apart, decouple it, take each factor, set equal to 0, and then I'm going to solve. So the real answer is x equals -4 or x equals -1. Okay, let me stop. Great problem to put on an exam. I want to see if this is making sense to you guys. Okay, good. Any questions about anything? Okay, so again, what you're going to need to do is you need to go back and look at your different factoring techniques and look at your special factoring properties for your binomials, sum of squares, difference of squares. Note that you can factor a difference of squares, you just cannot factor a sum of squares. That's going to lead you to a prime polynomial. Sums of cubes, difference of cubes, make sure you know those identities. You will see those on the exam, so make sure you do know those identities. Make sure you can implement the 0 factor property. We're going to keep using this property throughout the whole entire term as we're solving our systems, and this is going to be very, very useful as we go about our different equations. So make sure you spend some time reviewing these concepts, and if you need any help, let me know. Other than that, you guys have a great day, and I will see you next time.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.